In this section, we'll be looking at log analysis. So just small introductions or details about log analysis. Simply installing a firewall and IDS will not help you secure a network, and many people think that if you install a firewall or an IDS, it will perfectly protect, but unless it's properly configured, it won't help you. And even then, it needs constant updation in order to keep up with the latest attacks. And one should always frequently analyze the logs, because if you simply set up an IDS and don't monitor the logs, it's also a waste. And these analyzing logs will give you lots of things, like it will tell you if you're being attacked, or if there is a real APT attack being done against you, you can see it in the log. And this will help you prepare yourself, both like telling your employees that this company is facing a real attack, and that will make them more alert for APTs, and also that you can increase your security level in your firewall IDS and make their work harder. So like I said, you can even detect after an intrusion has happened, whether from the logs you can find if an intrusion has happened, and after it has happened also you can see how much data they took. All those details you can see in logs. So log analysis is a very important part of security. So what is SNOT? SNOT is an open source network intrusion prevention and detection system. It is developed by a company called SourceFire, and it detects lots of attack methods like denial of service, remote exploits, malwares. It can even detect if a port scan is being run, and a lot more. So this is the website for it, snot.org. You can visit it and check out about SNOT. So SNOT rules are very simple, and they analyze packets that come in, and you can choose whether they have to be logged or they should be ignored. So this is a simple rule for alerting if there is a ICMP packet from any IP address to any IP address, and if this ICMP packet is sent, then the message that needs to come in the log. So the message will be ICMP packet. So it's as simple as that. So this is what a sample log looks like. So you can see the alert for a ICMP packet over here, from which IP to which IP, what time, all those details over here. So one should always try to reduce the number of logs they get, because if a firewall or IDS is improperly configured, then there will be lots of false positives, and sometimes false positives and error messages can take up to 90% of the log size. And usually what happens is that if the log size is too big, then the real attacks get shaded over in comparison. So there'll be like 20,000 logs for false positives, and there'll be 2 real attacks. But because there are 20,000 false positives, you'll probably miss out on the 2 real attacks. So it's always best to reduce the number of logs. So optimization when it comes to firewall logs and IDS logs is that they need to be configured taking into account the network infrastructure. So based on what type of network you have, you should have rules according to that. And take for example, a Windows exploit is being run against a Linux machine. Then analysis of that log should have a low priority than something else. So let's look at an example of that. So let's consider this network setup. The attacker is in an external network over here. There is a firewall and IDS, and on this side there is the internal network. So there is a Ubuntu server over here. There is a user computer. There's a user computer. So one is Windows 7, one is Windows XP, and another one is Ubuntu. So Linux, Windows. So let's look at different attacks. Let's look at scenario 1. The IDS is detecting that a Windows XP exploit is being sent from the attacker to the Ubuntu server, that is 192.168.56.1, and since the Windows exploit will not work in Linux, its priority level will be very less, priority level 3. We just give it a priority level of 3, and the attack is happening at 10 AM. Let's look at the next attack at 10:30 AM. Scenario 2. The attacker is running a PHP MyAdmin exploit, is being sent from the attacker to the Windows 7 computer, and it is possible that the Windows 7 computer can run a web server and thus have PHP MyAdmin, but since it's not a web development server, it is it is less probability that it is actually having PHP admin. So, but it can still happen. So the priority level will be something like 5. So let's look at scenario 3, which happens at 12:30, and you can see that the IDS is detecting that a document containing an exploit for Office 2007 is being sent via email from the attacker to the victim, that is 192.168.56.3, which is a XP computer. And if you know the details of the applications running in that computer and you know that it's running Office 2007, then it will be a very high critical, because the exploit is for 2007 and the Office version running is 2007. So this exploit will work. So the priority will be 9.5. So when you're setting up IDS rules and firewall rules, it's also very good if you know the applications running inside each one of these systems, so that if an exploit is being run for that application, you will put a higher priority for that. So let's look at the next scenario 4, which happens at 2 p.m. The IDS detects that an Internet Explorer exploit is being sent from the attacker to the 56.1 computer, which is a Ubuntu server. Since Linux does not natively support Internet Explorer, the probability that this IE exploit will work is very, very, very low. So the priority level will be 1. So let's look at how the log analysis will be done before optimization. So you can see first over here that Windows XP exploit is being detected, and this is a very this has a very low probability of working. This has a medium probability, this has a very high probability, and this is probably never going to happen. But before, just imagine these are not 4 logs, imagine these are logs between 20,000 different logs. So it will take a long time for somebody who's analyzing logs to get to this, and by the time they get to this log, the attacker would have done his damage, taken all the data and left. So log analysis should be done like this. It should be according to priority. So when he's going down and looking at the logs, he will see this exploit, the exploit for priority 9.5 at the top. So he'll deal with this first, then go to the others. So this is how log analysis should happen. Thank you.